So, hello and welcome to week 9 problem solving session for the NPTEL course on environmental impact assessment. This course is being taken by Dr. Harshit Soshin Laka, who is an assistant professor at the Department of Architecture and Planning, Indian Institute of Technology, Roorkee. I am Isha Rathod, PMRF and Research Scholar at the Department of Architecture and Planning at IIT Roorkee. And this is Saturday's problem solving session. We have another session on Tuesday, which covers week 9 content again. So, in case you missed the session, you can take the Tuesday session as well. So, a few housekeeping rules before we start the session. So, please mute yourself for the session. If you have any questions or if you want to post the answers, you can do that in the chat box. If at different points, I will ask you if you have any queries. So, you can then raise your hand and unmute yourself for asking your questions. So, let's begin. So the session is outlined such that first we will look up at the highlights from each of the week from week 9's content. So we will look up at the key takeaways from each of the lecture units which we have covered in week 9. Then we will look up at assignment questions. So these are assignment questions which have been taken from the previous one of the same course, and they are for your additional practice apart from your assignment questions. So we will look up at solutions to those assignment questions with their explanations. And lastly, if you received any queries from you or if you have any queries relating to week's 9 content, you can ask them in the query session. And if we received any queries from you in the discussion forums, we will clarify those as well. Okay, so week 9 looked up at EIA reporting and review of the EIA quality. So let's dive into the highlights from week 9. So the first lecture was on lecture 41, which is EIA methods for ecosystem services. This is part 2. Lecture 40, which we saw in week 8, looked up at ecosystem services part 1. So in this lecture, we are looking up at scoping and baseline studies. So the purpose of doing scoping is to establish the ecosystem services context for a planned project based on what are the likely impact sources which are affecting the ecosystem services because of any of the development activities which are happening. Then we are looking about whether ecosystems are likely to be exposed to these changes and what are the beneficiaries or stakeholders who are going to be affected. So the purpose of doing the ecosystem services assessment is to see these impact sources which are impacting the ecosystem services. Who are the stakeholders who are getting affected, and what services or what ecosystems are likely to be changed or exposed to change. And then, based on these initial findings, the scoping phase should then confirm whether the proposed spatial scope or scale of analysis is okay, whether there is a proposed temporal scope, and the ecosystem services and their beneficiaries needs to be addressed in further steps of the environment and social impact assessment. So, based on the changes and the magnitude and extent and the other factors of the effects which we see on ecosystem services, we need to decide whether these we need to find mitigation measures around them basically, and whether something needs to be changed in the project scope. So for establishing a spatial scope for assessment purpose, we gather information on the locations of plant development, infrastructure and activities and their associated zones, and the impacts or the effect distances. So first we identify the areas of plant development. Then we see whether those distributions and how much they're affecting the ecosystems. So if any ecosystem service is getting affected, we need to identify them that based on the ecosystems, based on the development activities which are planned around it. Then we look up at if there are any direct land use changes which will happen, whether any ecosystems are within the functional connectivity, if on a larger scale the development is affecting any of these ecosystem services. Then, if a watershed is being affected, part of a watershed is being affected, then we consider the entire watershed in our assessment study. Can you please unmute yourselves? And also, if the land use change is happening because of any demographic change and improvement in infrastructure, we consider that also in our assessment purpose first. And distributions or locations of beneficiaries or stakeholders of ecosystem services who are affected based on the plant development and the infrastructure. So first we gather this basic information on what ecosystem services and what beneficiaries and what part is getting affected based on what construction activities have been planned, and then we consider all of this information further. So, based on the where key sources for information from where we collect the desktop-based study, where we collect information relating to your baseline study to establish your baseline. We can collect information like satellite imagery, aerial photographs, or other sources. We have several organizations from which you can gather this information. Then we can also have ecological assessments and reports focusing on ecosystem type, distribution, and condition, threats and pressures affecting ecosystem and how they have changed over time. We can also have information from reports and information on plant development and the design and location of plant infrastructure and activities. So from development plans, you can see what activities and other things are planned and how they're going to affect. Then we also have we can gather information from social reports and results of initial stakeholder engagement or consultation. So we get information regarding the demographic profile, the cultural beliefs and cultural value which this community holds, the economic characteristics and uses of or dependence of natural resources and ecosystem. So based on social reports, you can get this kind of information. So several organizations do undertake these kind of studies. So this information can be found online or from respective sources. So this information you can collect in your desktop initial studies. Then so, for example, now linking ecosystems with benefits. So, this is an example of how we can look up at how ecosystem services are getting affected. So, for example, if you have a grassland or a wooded grassland, so this is a type of ecosystem. So, the ecosystem services, there can be many others as well, but let's say the ecosystem service primarily is wildlife tourism. So, people come to this place majorly for tourism. So then the beneficiaries or stakeholders are your tourism operators, people who are like your agencies which are organizing tours around the site. Those are your initial or main beneficiaries. So their livelihood or their income comes directly from this ecosystem. So if you have a development which is planned there, the footfall of the tourists might reduce, and hence the tourism operators' income will take a hit. So that's an example of how ecosystem service is getting affected because of a new construction activity. Then you have tourists. Uh, their tourists benefit are the tourists are another beneficiaries or stakeholders in your this grassland ecosystem. So they the benefits which they get out of, or the ecosystem service which they get out of this uh, ecosystem, is the satisfaction with the visit. That is, they feel happy that they came to such a natural, beautiful place. So if there's a construction project which is happening, there might be dust which is being generated, or there might be noise which is being generated, and the tourists might not be happy with the kind of visit that they have planned. They wanted a natural, beautiful site, but they get to see like a construction and construction noises while they're visiting that site. So their satisfaction can get affected. So these are examples of how ecosystem services can get affected because of a new development activity which is planned. Similarly, you can have examples in other kind of ecosystems as well. So you can refer back to this unit to look up at all of these examples in details. Then we also looked up at network diagrams for understanding and communicating impact. So, for example, if you have a project for the rural road development, so now rural road development can affect your land and soil, your forest and air and water. All of these are, of course, interconnected as well. So it affects your land and soil in the conversion of like your agricultural arable land due to road construction. So there's a land use change which is happening from agricultural land to an infrastructure and amenities based land use. So there's a decline in crop production which leads to migration. So these are direct impact. The direct impact is decline in crop production, whereas the indirect impact is migration, because the people's livelihood has been affected. So earlier their livelihood was agriculture, which was a ecosystem service which they were getting out of the land. But now their livelihood has been affected, so they are forced to migrate. Similarly, you can see other kind of impacts which are also happening. So, for example, air and water, there will be emissions of air pollutants in the air. Then there will be flooding and siltation changes in river and hydrology changes. Changes in microclimate, decline in aquatic or terrestrial productivity, which will again change the employment opportunities and quality of life. So you see how different activities or the project can affect different parameters, and how the ecosystem services dependent on these environmental parameters affect are affected because of the project, and then you need to mitigate changes and see how mitigation measures can be planned around it. So this was the network diagram which was discussed. Then we also looked up at the ecosystem service causal chain diagram. So this is a diagram which shows how an action, stressor, policy, or project moves through an ecosystem to affect benefits to people. So you have an action, then you have certain ecosystem functions or ecological indicators, and then you, which is leading to benefits relevant indicators. This can be ecological or social database, and it can also impact a social value, so benefits assessment, value or preference. So how the ecosystem service, how an action affects the um, how an action or policy or a project affects the different stakeholders. So this was also discussed in this section, in this lecture particularly. Then we looked up at ecosystem service baseline assessment. So here, for determining the baseline, we have already looked up at desktop studies. Now we can gather required information based on the current level of ecosystem service supply, use, and benefit. We develop the interrelationships between the different supply, use, and benefits. What services affecting which stakeholder, and all of those relationships you need to establish. And then you see where this supply use, and there's an imbalance in the supply use and benefit chain because of any of the planned activities around your proposed development, and how they are causing threats and pressures on the people's livelihood, health, safety, and culture. So how they are basically affecting any of the ecosystem services which the stakeholders are dependent on. So this information you analyze and gather. Then secondary data which you can collect from different sources again is also land cover and land use mapping, vegetation survey and classification, survey of biodiversity and ecosystem, botanical surveys, agriculture surveys, social impact assessment, and results of stakeholder engagement, health impacts assessments, livelihood surveys, and water studies. So you can collect data regarding these as well. We also have something which is INVEST, which is the Integrated Valuation of Environmental Services and Trade-off. So this is a suite of model which is used to map and value the goods and services from nature that sustain and fulfill human life. So it helps explore how changes in ecosystem can lead to changes in the flow of many different benefits to people. So we have already looked up at the kind of benefits and the ecosystem services that people derive out of the natural resources or out of a particular ecosystem. So it basically maps and values the exchange of goods and services from the nature. So you can read more about it from the given link. We also looked up at priority ecosystems. So priority ecosystems are those for which changes due to a project are most likely to affect the well-being of beneficiaries or your stakeholders, because they depend on them to a great extent and have limited or no alternative. So for example, if we looked up at the rural road development example also, uh, because the land earlier, there's a land use change associated. The land earlier was an agricultural land, but now it is being changed to amenities or an infrastructure land use. The basic livelihood of people, which was agriculture, is being affected because of that development. So this is a priority ecosystem service kind of example, because priority the project is directly affecting the well-being of the people who were dependent on that land. Okay, so that is an example of priority ecosystem services. Then we how to identify so a decision tree for identifying priority ecosystem services which are affected by the project. So we ask questions like, can this ecosystem service reasonably be expected to be affected by the project? If the answer is yes, then you go down further. Is the benefit obtained from the ecosystem service likely to be affected? So whether it's yes or unknown, you go down further. Whether if the benefit is not something of for public use, then you say no. But if it is yes, then you go down further. So you ask questions and you determine whether the service is a priority ecosystem service or not. If your answer is no at any point, then it's a non-priority ecosystem service. So this is one of the methods which was discussed in the reference book which is cited. Then we also looked up at the engagement with the stakeholder for prioritizing ecosystem service. So you identify the ecosystem service which contributes directly to the livelihood or well-being. Then you establish how ecosystems and ecosystem services are used and determine whether this varies between different stakeholder groups. One group can use it for, let's say, cultural benefit. One group can have some sort of livelihood or income coming out of it. So different groups can use different ecosystem for different services. So you determine all the stakeholders and how they use it. Then you identify the use shed, that is where people access the ecosystem services they depend on. And you establish the extent of use, whether it's priority or whether it's fully dependent, their dependence and the benefits which they derive out of it. And then you engage in discussing the acceptability of alternatives. So because if you are taking somebody's, your project is affecting the financial financial status of somebody, like for example a land use change case, then you need to give them alternatives to for practicing their income or something like that. So you need to suggest alternatives which are acceptable to them and which leads them to a certain level of independence which they were having before your project was proposed as well. So you discuss these acceptability of alternatives which you are suggesting with your stakeholders. Then for scoping and baseline assessment outcomes, so at the end of scoping and baseline studies, you present a list of ecosystem services which are considered. Then you present the stakeholders to be engaged in further stages of the assessment process to confirm which ecosystem services are most important in terms of their dependence and the availability of alternatives. Then you also present a shared understanding of ecosystems, their types and conditions, and potential change in supply in the absence of the project, and their shared understanding of the level of use and type and the level of benefits which are derived from the ecosystem service and the potential changes in use and benefits in the absence of the project. So you present all of these in the outcome for the ecosystem services, a part of your environmental impact study. So your scoping and baseline study outcomes include your entry point for ecosystem service review or ESR. You establish the spatial scope, which we discussed previously, the sources of information and tools for scoping and baseline studies which you have used, the ecosystem service baseline assessment, priority ecosystem services which you have identified, and the scoping and baseline assessment outcomes. You include all of that in the report. Then moving on to the next lecture. Oh, no, this is the same lecture only. So then you do the impact prediction and evaluation. So so for predicting the impacts on ecosystem services, supply, use, and benefits, you see the impact. First, you see the direct drivers of ecosystem change, which are external to your project. So any changes in local land use, cover, harvest and resource consumption, pollution, species introduction, or removal, climate change. So you consider those. Then you consider your project environmental impacts. Then you consider those impacts on the ecosystem with what is the type of ecosystem service they are affecting and what is the condition. You you study the impacts on ecosystem service supply, what is the quantity, quality, timing, and location, and the impact on ecosystem service use, and the impacts and benefits which people get out of those ecosystem services. So you study all of those in terms of their whether their livelihoods are getting affected, whether their health is getting affected, the safety net which they have is getting affected, or their cultural beliefs or values are getting affected. So you do that study and then you use all of that in the impact prediction. And okay. And then you finally use that to derive your alternatives to this is the impact prediction, and these are the measures which can be undertaken to mitigation. Then you have discussions with the stakeholders or beneficiaries of these ecosystem services, and you come to acceptable alternatives with them. If they can't agree on an acceptable alternative, then you have to do a roundabout turn, or when you present your results, it will not look good in your EIA study, basically. So moving on to next lecture, where we looked up at lecture 42, which looks up at EIA methods for coastal ecology and geomorphology, part 1. Lecture 43 is part 2 of the same method, but it looks up at scoping and impact prediction. So we have looked up at coastal zones, the different kind of coastal zone regulations. We have the low tide shorelines and different areas. Uh, okay, we have looked up at all of these. Then we looked up at definitions and concepts. So when doing the coastal ecology and geomorphology and kind of assessment, we do this assessment first to if there are geomorphological landforms and processes, if they are integral to your components of coastal ecosystem. If you have a project which is planned around a coastal ecosystem and it's affecting the coastal ecosystem, then you do the coastal geomorphology and coastal ecology survey, or include this section in your EIA report. If it's not relevant, then you don't have to include this particular part. And when your project has a direct relevance to the risk of coastal erosion and flooding, so if any change can lead to direct or indirect impacts also, then you do this coastal geomorphology assessment and include it in your EIA study. So for doing the geomorphological information in EIA, we do two steps, which is the process and the material. So the process is we consider the winds, waves, tides, tidal currents, and sea level change and their strengths, directions, and variability with time. Uh, okay, we will share the presentations, and this video will also be uploaded in the YouTube for your reference later as well. I will talk about this later when I finish the review for this week. So, the essential material information which we gather around all of these geomorphology related parameters is you gather information regarding the geology of the coastal zone, offshore as well as onshore, including rock and softer sediments data. You look up at the topography and bathymetry or underwater topography and the type, that is the mud, sand, and gravel compositions and different parameters you look again here, and the distribution of mobile and non-mobile sediments. So sometimes waves and tides, they carry with them sediments and they carry them back. So you have mobile and non-mobile sediments. So you look up at that distribution as well. So these are data which you collect. Then you also look up at the interaction of material and process at the land sea interface. So you look up at what is the nature of erosion which is happening, how is the sediment transportation and deposition happening, what are the processes, how it's moving with the flow of the water. And you look up at the spatial and temporal changes in these processes over time. We also looked up at the different types of zones which are there. So we have supralittoral zone and we have the intertidal zone and the subtidal zone. And you find different species in all of these zones based on the, again, the tide zones which are there. So for these zones, we look up at different relationship to wave exposure. We have different typical locations of and relationship between the different zone habitats in relation to their wave exposures. So this was also something which we looked up at. And then we looked up at how these species have variations because of the substrate type, the variation in the water movement, differences in the salinity and turbidity of water. These are again water parameters. Then temperature and water clarity, topography and currents, light, how much light goes into the water, the geothermal activity. All of these are informations which you collect. Then for scoping, you include how much of the area is being impacted. So you look at it from a marine ecology point of perspective. You look up at the different habitats which are there, all of these different zones which we saw, what species are getting affected, how much, which zone is your development project affecting, what is the potential impact for detailed studies. Then you also look up at survey requirements and timing. So if your project is affecting, let's say, the middle zone, then how are you going to collect survey data? How are you going to assess the different species and what is the timing for which you will do the study? All of this needs to be undertaken and decided. So which is why you need to have experts also in these kinds of studies. Then for you need to determine the existing baseline data and need for detailed study. You need to do required coastal processes modeling studies if you can't you need to do like modeling studies to get more accurate data, and use methods for assessing the magnitude and significance of effects or impacts, including the total effects and the residual effects which are happening. So these are the things we considered when doing scoping for coastal ecology and geomorphology related studies. Then so you have certain for collecting your baseline study data, you can have different sources. So there are several Indian sources which are available for collecting secondary data. So you can use aerial photographs, satellite data, topographic maps, and bathymetric charts, or the um, underwater topography kind of charts. So there are several institutes which gives you data relating to different aspects. So you can use these organizations for collecting your data relevant to your particular development site. So you can read about them from the lecture or from this slide as well. So different institutes and what data you can get from them. Then for doing surveys, you can do geomorphological monitoring. So you have tidal current meter and wave stations. You can do sediment sampling, repeat bathymetric and topographic surveys, laser induced direction and range LiDAR, aerial photography. So all of these are methods for collecting data at site. Then you also have this wave data recording and processing techniques. So for recording the wave data, you have certain parameters, like you have the uh, different kind of basically instruments. So you have wave staff, you have a pressure recorder, accelerometer buoy, shipborne wave recorder. Then you need to have a data logger which is recording all of these data as well at whatever frequency you have set up. Let's say every second it's recording or every minute it's recording. So data logging is another aspect. Then processing this wave data. So you looking at that data from a statistics point of view, how much variation is there, how much, what is the maximum, minimum, what is the range in which it fluctuates. So all of this data then you process and present it in your AIA studies. Again, you need to discuss them with the experts to know what this means, and you need to bring in different experts at different points. And then for we looked up at the two main techniques for collection of the underwater topography data. So you have the single beam echo sounding, and the second one is the multi beam echo sounding. So this is also something which was discussed in this module. We looked up at habitat survey. So how do you survey the different habitats which we find in different tidal zones? So for doing ecological surveys of sublittoral or littoral habitats, typically comprise forms of mapping. So various techniques can be used here depending on the scale of the area which you are studying. So you can use remote sensing, aerial imagery, uh, together with ground truthing or substrate sampling. It can provide large scale information on the broad habitat types. Then, at a smaller scale, where more detail is required on the complex habitat, you can do walkover surveys for coastal habitats and intensive sampling. So you can do like grab samples, you can do video drop-down surveys in marine habitats. These can be employed where a diver drops down and it collects video recordings of the kind of habitats and species which it is seeing, and then you can identify from the video what species were seen and how it can, what numbers were seen, how frequently, what was their movement patterns and things. So all of this information you can derive from this video drop down surveys. Then moving on to lecture 43, which is again for EIA methods for coastal ecology and geomorphology. Here we look up at how to do scoping and how to do impact prediction for coastal areas if your development project is in such an area. So the key approach to identify impacts in coastal areas is to do the consultation with public, to do it with key marine users and regulatory authorities, and to do a review of the survey data which has been collected, the different sort of surveys which were undertaken. And if you had any similar case or construction project which has undertaken AIA when doing development in that area, you can refer to those cases also as case studies and look up at what kind of survey data they collected and what kind of methods they adopted. So for coastal ecology, assessment can be undertaken in two ways. So hydrodynamic effects or ecological impacts. So hydrodynamic effects and ecological impacts, They are categorized into four phases. So first is the identification of of the effect and the potential impact. The second is description of the effect and or impact. The assessment of the effect or the impact is third, and the derivation of impact significance. Okay. So causes and types of impacts in coastal areas. So for example, causes can be you have a project which is for large industrial and commercial development. So this can cause an increase in the water temperature because of the activities which are being undertaken, and this can change the biota. So these kind of effects you can map based on the kind of project type is there. Okay, so you have different causes again here. You can read more about them in detail. Then continued there as well. So then so for example, if we look up at different sources and the types of impacts. So for example, if you have like an urban development, so it can cause runoff into your areas. It can lead to soil erosion, the nutrients and toxic pollutants loading, which can cause bioaccumulation and eutrophication. So if you have a project like oil and gas exploitation, it can cause disturbance to marine species and ecosystem. There's a hazard risk always associated with an oil and gas exploitation kind of plant, that it can lead to this oil spills, accidental oil spills, of course. Then, if you have a wind farm, it can lead to sediment plumes. It can cause changes to sh- uh, it can cause basically different changes to the noise levels. It can increase those noise levels and things like that. So different kind of projects can have different impacts, of course, on the coastal area. So you map all of these impacts. Then you can use different methods for impact prediction and assessment. So here are a few for doing the noise, for predicting impacts for noise environment. So you have the FHWA, or the Federal Highway Administration model, which considers the noise impact due to vehicular movements on highways. Dhwani, which does predictions of impact due to groups of noise sources in the industrial complex. The hemispherical sound wave propagation for airport model. This uses predictive impact due to single noise source, predictive impact of traffic on airport and railroads. So these kind of impacts models basically you can use for doing impact predictions and assessments. For water environment, you have different models, which again which simulates the tides, currents, and discharge based on the different situations which are there. It can simulate the movement of sediments and things based on the parameters which you have set. Different surface profiles can be generated. Water surface profiles. So all of this can be circulated based on different models. So these are the few models. Similarly, you have models for land environment, for biological environment. So all of these can be undertaken in your EIA studies for relative to your coastal areas, and then the findings can be presented. Okay. Then, in terms of how you do impact prediction for species, you have we have looked up at species in the like week 8 review. Also, we have looked up at species. So for species, also you can do similar kind of impact assessments methods. Now, how to do impact assessment? So impact assessment or effect assessment is done based on a few parameters. So you look up at the scale of the effect, whether it's affecting a larger number of species population, whether that the spatial extent of that impact is large, or is it small? What is the duration? Is it short lived, or is it a long term effect? Whether the impact is reversible or irreversible, what is the frequency of it happening, what is the likelihood of it happening if it's a risk related kind of situation, vulnerability of the different stakeholders or species which can get affected because of this that effect, the sensitivity or intolerance, recoverability, value or importance, whether it's being affecting the value of the environment or not. So you assess the effect based on all of these parameters, and then you say which effect is more significant and critical, that mitigation measures need to be undertaken for that, and things like that. So this is how you present the effect again. You present the effect basically for all kind of uh, EIA parameters like that only. So same applies for coastal habitats, projects in coastal habitats as well. So again, different criterias are there for the kind of how you define the magnitude for marine ecology. So for marine ecology specifically, a high magnitude could be something which affects the quality and availability of habitat and species. If they are degraded to the extent that locally rare populations and habitats are destroyed, that protected species and habitats experience widespread change and such that the integrity of the ecosystem and the conservation status of a designation may be compromised. And the activity is predicted to occur and affect the receptors or people on which this effect is being calculated, people or species, flora or fauna, continuously over the long term and during sensitive life stages. Recovery, if it occurs, would be expected to be a long term, that is 10 years following the stopping of that activity. So, impacts not limited to areas within and adjacent to the development. So, certain criteria can exist which determine what that a high magnitude of impact could mean relating to marine ecology. So you can read up again on the magnitude. So for marine ecology, we also have how it affects the value and sensitivity based on the different parameters. So again, all of this was discussed in lecture 43. Then moving on to lecture 44, here we looked up at AIA methods for noise. So first we looked up at the basic principle of vibration. So how noise moves from a vibrating object and how it is heard by the human ear. We discussed all of that. Then we looked up at the vibration frequencies. So for humans, 1 to 80 hertz is perceptible to humans. We can hear 1 to 80 hertz only. And a particle may vibrate. It can vibrate vertically, it can vibrate longitudinally, and it can vibrate horizontally. So vibration levels are commonly quantified in the noise assessment reports, noise assessment section of the EIA report in terms of the peak participle velocity, PPV, and it's measured in millimeters per second of vibrations. And the threshold of human perception of vibration is typically within the range of 0.14 millimeters per second to 0.3 millimeters per second, peak particle velocity or PPV. Then we looked up at certain definitions and concepts like noise is essentially unwanted sound. Noise impact assessment is the revolves around the idea of quantifying and objectifying people's personal and subjective responses to noise. Sound consists of pressure variations that are detectable by healthy human ears, and these pressure variations have two characteristics, which is frequency and amplitude. So, frequency refers to how quickly the air vibrates and how close the sound waves are to each other. So, frequency is expressed in cycles per second or hertz. The audible frequency we have seen is approximately 20 hertz. The highest is 20,000 hertz. Then environmental noise is dominated by a particular frequency and it may be described as a broad band. So it comprises a range of different frequencies. So noise sources can include anything which generates noise which within different frequencies. So it can be anything like your turbines, compressor, cooling fans, automobiles, some other rogue source, things like that. Then the audible frequency spectrum is divided into standard octave bands. So every 32, 60, 64, 125, 250, 500, 1000, 2000, 4000, 8000 hertz. So all of these are audible frequency spectrums. The sound amplitude refers to the amount of pressure exerted by the air, which is often visualized as the height of the sound wave. So the when the sound wave is formed, the amplitude is this much the variation, and it's described in the units of pressures per unit area or micropascal. Pascal actually, micro is the term which we just associate because it's in that range only. The amplitude is sometimes converted to sound powers in picowatts or sound intensity. So again, all of this was discussed. The formulas of sound power and sound intensity were also discussed. What were their baselines? So again, from the examination point of view, remember the definitions and concepts, the units which are associated with each of the values. If there are formulas associated with certain parameters, you can get questions around numerical calculations from those formulas. So three important things which will come out of this lecture unit are these three. So sound intensity is the subjectively it's what the loudness of sound that is being felt by by the listener. So it's expressed in the logarithmic scales of decibels, and it's calculated by the given formula. So 10 log to the base of 10, amplitude of pressure fluctuations to rho, which is 20 micropascal. So this is the lowest sound audible to healthy human here. So that is the baseline case which is considered. So it's the square of the p by p, the amplitude by the 20. So p by 20, if you can just remember this formula as. But sound intensity is what loudness a listener feels. Then sound power level is again given by a formula which is 10 log to the base 10 W by W square. So W is the sound power, where small w is again established from a base case of 10 to 12 watts. Again, this will be given in the numerical. So you can calculate the sound power level if you know the source sound power. Okay, so sound power level is the energy output of a source. So how much energy it is giving out. So it's calculated usually for equipments under carefully controlled conditions. Then, then we have measurements for noise characteristics. So characterizing noise over time. So noise levels are rarely steady. They usually fluctuate. They rise and fall in accordance with the activity taking place in the area over the given period. Why we consider noise particularly is because we have a lot of development activity when a project is proposed. So we consider what equipments are going to come in, how much noise it's going to produce. Based on what is the activity which is proposed, how long it will take for completion, what is the management plan for it. So you consider noise in AI assessments because it is sensitive to different stakeholders. Okay. For the principal measurement index for environmental noise is the equivalent continuous noise level, or the LAQ. LAEQ or LAEQ. So this is the notional steady noise level, which over a given time would provide the same energy as the time varying noise. So it's calculated by averaging the sound pressure or power or intensity measurements with a bias towards the louder noise events and converting that average into the decibel scale. Okay. So factors which influence noise impacts, these are your level of the sound, the context or location, distance from a source of sound, the wave expansion pattern for the noise and the line noise source, the presence of obstruction is if anything is obstructing that noise source, it will cause the sound wave to change paths, and it can create an effect. So the presence of obstruction is also considered. So for example, if you are building in trees, some materials absorb noise as well, so that can also be considered. So if the sound is traveling over a reasonable distance, the type of ground over which it is passing can have substantial influence on the noise level at the receiver. If there are acoustically hard surfaces which do not absorb sound, which basically reflect the sound which is falling on them. Meteorological effects, environmental conditions such as wind velocity, direction, and temperature. So these are all factors which influence noise impacts. Then we have certain guidelines around noise analysis. So we have the Federal Highway Administration FHWA's noise abatement criteria (NAC) that gives you procedures which can be used in planning, development, and design of highways. So this is one guideline. Then we also have the Central Pollution Control Board (CPCB's) guidelines for noise. Okay. Then we have different perception scales, so noise exposure hierarchy. So we have different perception of how we perceive noise and what outcomes and actions are advised in certain situations. So if you have a not noticeable noise, it basically has no outcome. You don't notice as only it's like a white noise which is happening in the background. So there are no specific measures around it. But if you have something on the other extreme end of it, which is like a noticeable and very disruptive kind of noise, listening to it over a longer period can cause extensive and regular changes in behavior. It can make you more irritable, or it can have an inability to mitigate effect of noise, leading to psychological stress or physiological effects like regular sleep deprivation or awakening, loss of appetite, significant medically definable harm to your auditory functions. So the action advice for this kind of noise is preventive, that you need to prevent any such kind of noise happening. So this is the noise perception or noise exposure hierarchy. Then for doing scoping and baseline, we discussed the scoping and baseline studies for how to do for noise assessment. So we have sound measuring equipment. So you have microphone, sound level meter, analyzer, reference sound source, and you have different types of settings for measuring these equipment. So these kind of equipments can be used in your baseline studies. Then how to do noise measurements data collection. So first you determine what equipment needs to be used. You need to get familiar with that equipment. The take note of the date, weather conditions, wind speed, wind direction. So meteorological conditions you consider. You calibrate the equipment, the sound meter and microphone, setting up the microphone at the appropriate site, calculating the distance from the noise source where measurements are taken, taking measurements using the criteria from the relevant guidelines, using these weights which we see in the previous slides, the noting the start and finish times, having that frequency setting every 10 minutes or every half an hour it's taking the recording, and then checking the calibrations whether the data which we are getting is correct or not. So that's how you do data collection for noise measurements. The important thing is to know which equipment you are using, how that equipment records data, what assumptions and what kind of environment conditions are being considered on the site when this data is being collected. So these are the main things, and calibration of the equipment again to see whether it's relevant, it's giving the relevant or correct results or not. Then why we do impact prediction and evaluation for noise? It's to identify the changes in noise levels which may occur both in the short and long term, and to determine the significance of the change. Then we do look up at noise level variables. So existing and likely future baseline noise levels, the type of equipment, both mobile and fixed use at site, duration of various stages of construction and operation, the time of the day when the equipment is used, actions of the site operator, the location of the receivers and their sensitivity to noise, topography of area, including the main forms of land use and any natural sound barriers, meteorological conditions in the area, the amount and type of sound coming from the site, how that sound travels, and the response of the receptors to the sound levels which they are being subjected to. Okay, so these are all things which we look at when doing noise assessments. So this is a example just to see what kind of sound levels construction equipments generate. So bulldozer generates a sound level of uh, 80 decibels at a 10-meter distance. So if you are standing 10 meters from a bulldozer, you get 80 decibels of sound. So for a lot of these construction related activities have sound levels in the range of 65 to 90 or 100. So that's a significant amount of sound which you are being forced to. And this is especially at a 10-meter distance. If that distance is lesser, it's more significant what you are listening to. So that is why we do this impact prediction and evaluations, because these construction activities generate a lot of noise. Then we again have certain calculations based on what is the source of so the equation to determine the reduction in noise due to distance attenuation. So if the distance is reduced for different, if the receptor distance is reduced, then the noise which you are listening will also reduce. So this is based on that. Then you have one for similar thing for line noise source. Then we have calculations for sound power data, again, a lot of numericals. So you can make a note of numericals and what they mean. And these kind of questions can come in your examination, especially from this lecture unit, because it has a lot of calculation based numericals. So these kind of questions can come. So again, numericals, formula based numerical questions can come out of this unit. So please make a note of this when you revise this lecture further down when you have the exam. Then we again have the guidelines for predicting the outdoor sound. So certain standards and things which are available. And we also have softwares which can model the sound effects. So we have two softwares, which is SoundPlan and Cadna. So both of these can be used in modeling for noise assessments. Okay. So again, this can also be used for traffic kind of projects. So traffic noise modeling can also be done. This is another model which we discussed in this week. Then how we calculate the impact, uh, the significance of impacts. So high sensitivity to noise can lead to receptors where occupants or activities are particularly susceptible to noise. So examples of these kind of situations are residential accommodations or private gardens which are near to your development site. If there are hospitals or residential care homes, they have certain sound levels which are advised to be followed near these kind of uh, building types like hospitals or schools in daytime. So if you have these kind of uh, land use or these kind of building types in your adjacent or near to your proposed development site, then you need to be very careful and sensitive to doing the noise assessment. Uh, okay. So again, different kind of receptors have different sensitivity to noise. So negligible sensitivity could be like your car parks, nightclubs, agricultural land, where having a larger noise coming out of your construction site will not affect the different people or building types which are adjacent to you. But if it's something like a hospital or a school, it will lead to complaints and sensitive issues when the construction begins. Okay. Then the last lecture for this week was AIA methods for transport. So first we look up at definitions and concepts, the different modes of transport, cycling, walking, public transports, private transports. We looked up at different kinds of journeys. We looked up at diverted journey, pass by journey, original journey, or linked journey. So that we discussed. Then we looked up at how to do a transport baseline and environmental baseline. So if we are doing a baseline study for a length of road at a particular time, so with reference to that, we look up at the highway width, structural conditions, link capacity, junction capacity, driver delay or queuing times, average speed of travel, turning movements, number of accidents, and the type of accidents, slight, serious, and fatal. The proportion of heavy goods vehicles, number of bus movements, pedestrian and cycle flows, the location and type of on-street car parking, and the nature of frontage land use. For rail and tramway networks, we have different kind of factors which are relevant. So line capacity, whether it's single loaded or dual loaded. Uh, the station capacity, how many stairwells are there, how many movement of people can happen, platform width, platform length, the rolling stock passenger capacity, the frequency of service and station wait times, time delays at any railway crossings, the junction capacity and signaling, layover capacity, proportion of freight trains versus passenger trains, the proportion of stopping and non-stopping services, the speed of movement which is seen on these kind of networks. So different factors for different kind of transports we see. For cycling and walking, we consider parameters like pavement or sidewalk width, network standards, destinations, incorporation of existing routes, journey lengths, user groups. Then based on this, we categorize environmental effects from transport. So we look up at air quality and greenhouse gases. So we look up at how they are being generated. Then if there's a new proposed development relating to, let's say, a transport related thing, we look up at dust from construction, the air pollution, carbon emissions during construction. Uh, these kind of things basically you consider when you have a transport kind of project. Then how it affects the communities and economic activities, whether new economic activity is generated, whether community severance is happening, reduce convenience of traditional and sustainable modes of transport, whether it's affecting that. So all of these things are considered, whether cultural heritage or loss or damage to any heritage resource is happening. All of these are again things which we consider when a transport project is proposed. Whether there's a loss of biodiversity or ecological ecosystems which are being affected, whether associated impacts or effects could include effects of air and water pollution, disturbance by noise and light, fragmentation of habitats, which we would have seen if a straight line comes in. You see the edge effects which happen because of the new development which happens. So, all of this health and safety, indigenous people or vulnerable groups. So, all of these effects we discussed. Noise and vibrations again, soils, water resources, landscape, and townscapes. So, we discussed the category of effect and the effects which arise because of development of infrastructure, transport kind of projects, and their additional effects. Okay. Then we also looked up at certain softwares which can be used for impact modeling. So this was all which we discussed in week 9. So if you have any questions, maybe you can unmute yourself now and ask, or you can put that in the chat box before we go into the practice questions based on this week's content. Okay. As per whether we will share, I will share this PPT with you as well. Uh, in the same folder where we share all of the problem solving sessions. You can find them in the in your so where you see the week content, there's a tab which says problem solving sessions. So it has the link to the folder in which we upload all of these presentations, and we also have the YouTube link for the each of the week's lecture problem solving sessions which we have taken. So you can find those links there as well. So if there are no questions, let's go into the practice questions for week 9 content. So you can post the answer for the question in the chat box and I will regulate the chat box. Okay, so the first question is scoping purpose for establishing the ecosystem services context for the planned project is based on the following. Looking at the likely impact sources, B, ecosystems which are likely to be exposed to change, C, beneficiaries who could be affected, or D, all of the above. Okay, so we have one answer D. Okay, so D is the correct answer for establishing the scoping ecosystem service context for the planned project. We focus on the likely impact sources, which are coming out of your construction activities of the post development plan. Then the ecosystems which are likely to be exposed to change, and the beneficiaries who could be affected or the stakeholders who could be affected who are deriving the ecosystem services. So all A, B, and C are correct. So D, all of the above is the correct answer. Moving on to the next question. So, for baseline assessment of ecosystem services, following information are needed. A, current level of ecosystem service supply, use, and benefit. B, interrelationship between supply, use, and benefit. C, future supply and use in the absence of the planned project, taking account of existing threats and pressures and their relationship with people's livelihood, health, safety, and culture benefits. So, or D, all of the above. So for establishing the baseline for ecosystem services, what information is considered? Okay, we have one answer all, which is D. Okay. So D, all of the above is the correct answer. For establishing the ecosystem baseline assessment, we consider A, the current levels of ecosystem service supply, use, and benefit. We consider the various interrelationships between the supply, use, and benefit. And we consider the future supply and use in the absence of the planned project. That is, the project is not considered. Taking account of the existing threats and pressures which they are facing, their relationship with people's livelihood, health, safety, and culture. So D, all of the above is the correct answer. Moving on to the next question. So fill in the blank. So this is from the tide section. So this is from the lecture where we look up at the coastal geomorphology and ecology. So there are three zones which we saw as the tidal zones. So you need to mark the order of the tidal zones. So fill in the blank space of P and Q to complete the list in correct sequence of tidal zones. So what is P and Q in the given form? So which zone is above and which zone is below? Okay, so this can be slightly tricky. So the correct answer is B, that is P is the superlateral zone, that is the first zone which we see, and Q is the zone which follows the superlateral zone, which is the intertidal zone, and then we have the sublateral zone. Okay, so the correct order is P is superlateral and Q is intertidal. So B is the correct answer. Okay, moving on to the next question. So match the variety of coastal landforms given in group A with their description given in group B. So we have different types of coastal landforms and their images and photographs. So you need to match group A with group B. Okay, we have one answer B. Okay, so the correct answer is A, that is beaches is P matches with 2. So beaches are accumulation of loose sand or shingles that change shape in response to the changes in the wave energy and maintains itself in a state of dynamic equilibrium with its environment due to mobility of the sediment. So those are beaches. So P matches with 2. Then spits are where a coastline turns abruptly inward, such as when where a bay or valley opens onto a coast. A finger-line extension of the beach, it may project out across the indentation. So you see this kind of landform. So these are spits which are formed because of the movement of basically the abrupt movement of coastline which you see. So these are spits. So Q matches with 1. Then dunes are matches with 4, which is dunes form where a supply of dry sand and winds to move it exists together. So you have dry sand and wind together. So that is why dunes form. So these systems are usually fronted by sand beaches and or sandbars, which are exposed to low tide, with which they have a close association. So R matches with 4. And then muddy shorelines are common along the upper levels of the intertidal zones of estuaries and sheltered tidal embayments. And they form where tidal current velocities are too weak to resuspend completely the mud that settles out at high water slack, thus permitting the net accretion necessary to form mudflats and salt marshes. So S matches with 3. So A, that is P matches with 2, Q matches with 1, R matches with 4, and S matches with 3 is the correct answer. Okay. So moving on to the next question. So state true or false, single beam echo sounding and multi-beam echo sounding are techniques used for the collection of bathymetric data. For coastal habitats, we looked up at bathymetric data methods. So this is how underwater topography is mapped. So whether the two techniques which are mentioned here are used for bathymetric data or not. Okay, so we have one answer A. Okay, so A is the correct answer. So there are two main techniques which are used for the collection of bathymetric data, and they are both mentioned here, which is single beam echo sounding and multi beam echo sounding. So when beams are projected onto the landform which is under the water to see how far it is and what different kind of variations which can be mapped on it. So basically get an idea of what that landform looks like, the different zones which we saw. So these kind of techniques are used for underwater topography mapping. So single beam echo sounding and multi beam echo sounding are techniques used for collection of bathymetric data. The statement is true. Okay. Match the following models for prediction of impacts of water environment given in group A with their application in group B. So we have different models and their applications for what they are used for, what kind of impact prediction they are used for. So these kind of questions can come out of where we have discussed models in depth. So you need to match the type of model and their application. So this is again from the coastal ecosystems and geomorphology. Okay, so the correct answer is C. So estuary models or estuarial dynamic models, they are used to simulate tides, currents, and discharge in shallow vertically mixed estuaries excited by ocean tides, hydrological influx, and wind action tides. And currents and estuaries are simulated. So P matches with 2. Then dynamic water quality model is used to simulate the mass transport of either conservative or non-conservative quality constituents, utilizing the information derived from the hydrodynamic model. And you can model up to 10 independent quality parameters of either conservative or non-conservative type, plus the BOD or DO coupled relationship can be handled. So Q matches with 3. Then HEC2 is used to compare water surface profiles for steady, gradually varying flow in both prismatic and non-prismatic channels. So R matches with 4. And SMS model is used for modeling lake circulation, salt water intrusion, surface water profile simulation model. So S matches with 1. So the correct answer is P matches with 2, Q matches with 3, R matches with 4, and S matches with 1. So again, these models and their applications, because we have seen a lot of models and their applications. If you remember a few of them, it can help you answer these kind of questions. And these can come in your examinations as well. Okay, so the correct answer is C. Moving on to the next question. So match the following terms of group A with the description given in group B. So these are all terms we looked up at in the noise assessment lecture. So we have all terms relating to noise parameters. And in group B, we have their descriptions or definitions. Okay, so the correct answer is D. So vibration refers to the oscillation of an object about a reference point with the number of oscillations per second giving the frequency of vibration. So P matches with 4. So vibrations and the oscillation of a object basically. So P matches with 4. Then Q sound power level matches with 1, which is the energy output of a source calculated from measurements made around the equipment under carefully controlled conditions. So Q matches with 1. Then R sound amplitude matches with 2, which refers to the amount of pressure exerted by the air, which is often visualized as the height of the sound wave. So R matches with 2. Then sound frequency or S matches with 3, which refers to how quickly the air vibrates or how close the sound waves are to each other. And this is measured in cycles per second or hertz. So sound frequency S matches with 3. Okay, so the correct answer is D, that is P matches with 4, Q matches with 1, R matches with 2, and S matches with 3. Okay, so moving on to the next question. Scoping and baseline studies for noise includes the following. One, identify the relevant potential sources of noise. Two, identify the receptors, that is the people and the sources likely to be affected by noise from the proposed development. Three, identify the monitoring locations for baseline data collection, that is where you will put up the measurement equipment. And four, check the national or international guidelines and standards which will be applicable to the case. So which of the given statements are correct? So you have the different statements. Okay, so we have one answer D. Okay, so D is the correct answer. That is, all of these are considered in the scoping and baseline studies for noise, including the identifying the sources of noise, the receptors who are going to be exposed to these noise, then identifying the locations at which you're going to put up the measurement equipments, and using the national international guidelines and standards to see what are the acceptable noise levels at different locations at different distances from the source of sound or noise. So D, all of 1, 2, 3, 4 is the correct answer. So all of these statements are true. So moving on to the next question. So the basic equation given below is used to calculate distance attenuation due to geometric dispersion by using the following method. So what is this method? Is it A, sound power data, B, point noise source, C, line noise source, or D, none of the above? So we have one answer B and one answer A. Okay, so the correct answer is A, that is this equation. LP1 is LW minus 20 log R minus 11 is the formula which is used for the calculation of sound power data. Okay, so A is the correct answer. Moving on to the next question. Which, with reference to the diagram, match the following trips in group A with their description given in group B. So we have A is our point A and this is our point B. So we have the trip based on how the route changes. So what is, you need to match group A, which is the trip type, to their description, which is written in group B. Okay, so the correct answer is B. That is, new trips are those which did not occur anywhere else on the transport network prior to the development. So if a new development happens and you have to undertake a new route because of this this development, so that route is known as a new trip. So those that did not occur anywhere else on the transport network prior to that development. So P matches with 2. Then Q, pass by trips, match with 1. So these are made as part of another journey, such as stopping off on the way home from work. So those are pass by trips. Then R, transfer trips, match with 3. That is, these are the trips that are already being made and that would be transferred to the proposed development. So those are transfer trips. Then S, diverted trips, match with 4. That is, they're similar to pass by trips, but they involve a longer diversion from the existing route to the site. The next statement is not related to the diverted trip statement. But these are the descriptions of the different types of trips we see. So P matches with 2, Q matches with 1, R matches with 3, and S matches with 4 is the correct answer. So these are all questions which were there in the previous run of the course. That is last year. These were the questions which were in the assignments. So again, these type of questions based on images, descriptions, and discussions which were seen in the lectures can also come in your examinations. So please look up at the figures and understand the meaning of those figures as well. Okay, so moving on to the next question. So, which are the softwares which are used for transport impact prediction? A. Saturn, B. Cube, C. EMME, or D. All of the above? So, this was the very last slide which we saw in the highlights video as well, in the highlights section for this week. Okay, so we have one answer D. So D is the correct answer. That is, all of these are tools or softwares which are used for transport impact prediction. So you have Saturn, Cube, and EMME. So moving on to the next question. So state true or false. Software Picardy or priority intersection capacity and display is used for predicting capacities, queues, delays, both queuing and geometric, and accident risk at priority intersections. Is the statement true or false? So again, this is a software-based questions, which is used for, again, transport-related or software impact predictions. Okay, so we have one answer A. So A is the correct answer. That is, the software Picardy is used for predicting capacities, queues, delays, and accident risk at priority intersections. So you can simulate all of this based on the data and inputs which you give it. So the statement is true. Moving on to the next question. So choose the correct order of components to complete the ecosystem service causal chain diagram. So we had different elements in the ecosystem service causal chain diagram. We had action, ecological indicators, the benefits, relevant indicators, and benefits assessment. So what is the order in which this diagram is seen, or the order of the different components? So again, this is a figure-based kind of question. Okay, so the correct answer is A. So first we have the action, then we look up at the ecosystem functions, so the ecological indicators. Then we look up at how the ecosystem services being utilized, or if it is being utilized based on the benefits relevant indicators, based on the ecological and social data. Then we look up at the social value of the uh, based on the benefits assessment or the value or preference. So this is the ecosystem service causal chain diagram. So the correct order is action, ecological indicators, benefits relevant indicators, and benefits assessment. So A is the correct answer. So moving on to the next question. So in the context of EIA for ecosystem services, ESR refers to A, ecosystem service review, B, economic and strategic review, C, ecological systems enumeration, or D, environmental service resilience. We have one answer A. So A is the correct answer. Ecosystem service review is known as ESR in the context of ecosystem services. So A is the correct answer. Moving on to the next question. So, which of the following contributes directly to changing shorelines and coastal areas? A, tidal current. B, sea fish. C, fishing ships. D, boating and surfing. Which of the following contributes directly to changing shorelines and coastal areas? So, the keyword is directly. So, it is a direct contributor to changing shorelines. Okay, we have one answer A. So A is the correct answer. So tidal current directly contributes to changing the shoreline in coastal areas because of the movement of the waves. the movement of sediments is being ensured. So the shorelines can change because of the tidal currents, whereas sea fish, fishing ships, boating, and surfing, they contribute indirectly to the coastal areas and the impacts on coastal areas. Okay, so A, tidal current is the correct answer. Again, read the question carefully and look up at key terms. So they will help you look at the question from the perspective of the question asker. Okay, so directly was the keyword in this question. So moving on to the next question. State true or false. The coastal geomorphology directly impacts coastal erosion, but one should consider it for aesthetic reasons as well. Is this statement true or false? Okay, we have one answer A. Okay, so A is the correct answer. So coastal geomorphology directly impacts your coastal erosion, which is happening, but you also consider it for aesthetic reasons. One of the reasons for this is because a lot of coastal regions have aesthetic value associated with it. That is, the coastal beaches or these kind of areas, they generate a lot of tourism related benefits as well. So that is one of the financial sources of a lot of population which lives up on that in the coastal region. So we consider it for aesthetic reasons as well. Whereas coastal region is the primary factor which we consider the social geomorphology for. Okay, so A is the correct answer. So true, the statement was true. Moving on to the next question. So, dash, also known as tidal flats, are coastal wetlands that form when mud is left behind by tides or rivers. They are found in sheltered regions such as bayous, lagoons, estuaries, and bays. So, again, a definition of a different type of term for coastal landform. So, is it A, abysmal plain, B, mudflats, C, aphotic zones, or D, benthos? So, we have one answer B. So, B is the correct answer. So, mudflats, which are also known as tidal flats, are coastal wetlands that form when mud is left behind by tides or rivers, and they are found in regions such as bayous, lagoons, estuaries, and bays. So, again, these kind of definitions were discussed in the lecture, the actual lecture video, which ma'am have discussed. So, B is the correct answer. So again, terminologies relevant to each of the lecture units are important. Moving on to the next question. So which of the following are key approaches in identifying environmental impacts in coastal areas as per the methods of environmental and social impact assessment? Roy Emberton, Richard J. Wenning, and Joe Trevick, 2018. So it's a multiple select question, hence MSQ. A, public consultation, B, review of survey data, C, consultation with concerned authorities, or D, opinion of residents in nearby cities. So more than one options can be correct in this question. So what are the key approaches which we use in identifying the environmental impacts on coastal areas? Okay, we have one answer C. More than one options can be correct. So, okay, we have D. Okay. So the correct answer is A, B, and C. That is the correct answer. So public consultation is used, the review of survey data is used, and the consultation with concerned authority is are key approaches which are considered for identifying the environmental impacts in coastal areas. Whereas the opinions of residents in nearby cities is not considered because they don't have a direct association with the coastal area because they live in nearby cities. They are not the stakeholders or beneficiaries of the coastal habitat. So A, B, and C are the correct answer. So moving on to the next question, arrange the following phases of hydrodynamic and ecological impact assessment in their correct order. So identification of the effect and potential impact. Second is description of the effect and or impact. Third is assessment of the effect and or impact. And fourth is derivation of impact significance. So we looked up at the four phases of the hydrodynamic and ecological impact assessment in the revision and review of the sessions. So what is the correct order? So we have one answer A. So A is the correct answer. So the first step is identification of the effect or impact. Second is describing that effect or impact. Third is assessing that effect or impact based on the different methods. And fourth is the derivation of impact significance based on the different parameters, whether it's of high significance, low significance, non-significant. So the correct order is 1, 2, 3, 4. So A is the correct answer. So moving on to the next question. So match the consequences of urban development in group A with their impact on the environment in group B. So these are consequences of urban development on the environment. Here we have one answer A. So A is the correct answer. So increase in runoff during heavy rains can lead to flash floods. So P matches with 3. Soil erosion Q can lead to suspended sediment loads. That is Q matches with 2. Then sewage discharge from urban areas can lead to eutrophication because of the large amount of nutrients being present. So R matches with 1. So the correct answer is P matches with 3, Q matches with 2, and R matches with 1. So A is the correct answer. Okay, so moving on to the next question. So BS 52282, BSI 2009 indicates that construction activities generally only cause vibration impacts when they are located less than dash meters from sensitive locations. So is it A 5 meters, B 20 meters, C 100 meters, or D 500 meters? So you're talking about vibration impacts up to a certain location from construction activities, like up to a certain distance. What is that distance until which vibration impacts are being faced? Okay, we have one answer C. Okay, we have another answer C. So the correct answer is B. That is, the vibration impacts are felt um, until 20 meters from sensitive locations. So until construction activities generally only cause vibration impacts when they are located less than 20 meters from sensitive locations. So B is the correct answer. This is from the building standard, which we looked at in the noise assessment. Okay, again, these kind of baseline data and benchmark data or I would say standards which are relevant can also be asked in questions. So especially from noise, because we looked up at different formulas and different standards only in noise. So these questions can come out of this module. Okay, moving on. So which of the following is an uncommon noise source in the context of environmental and social impact assessment? A, road traffic, B, railways, C, construction, D, crying children. It's a very funny question. Okay, so D is the correct answer. So an uncommon noise source in the context of AIA is D, crying children, whereas all three, that is road traffic, railways, and construction, are considered as noise source in the environmental impact assessment. Okay, moving on. So match the correct units in group B with what they are used for measuring in group A. So we have the terms and their units. So again, these are from the noise module because we have looked up at a lot of technical data in the last lecture, uh, the noise lecture. Okay, so the correct answer is B, that is sound frequency is measured in hertz, sound amplitude is measured in micropascals or pascals, and sound intensity is measured in decibels. Okay, so P matches with 1, Q matches with 2, and R matches with 3 is the correct answer. So B is the correct answer. Okay, moving on. So state true or false, non-transport development such as afforestation also require Also require the AIA of transport to be considered as part of the complete AIA process. So non-transport developments, such as if there's an afforestation as well, also require AIA of transport to be considered as part of AIA project, AIA process. Okay, we have one answer A. So A is the correct answer. Even though if we are doing afforestation, we do EIA and we do EIA of transport in that project as well, and we show if there are positive effects coming out of it as well. Okay, so the given statement is true. Okay, so if you have any queries, you can either put them in the chat box or you can just unmute yourself and ask based on whatever we discussed and based on whatever you have seen in this week's content. Because we did not receive any queries from you in the discussion forum. So if you have any questions or queries, you can put it in the chat box, just unmute and ask.
Actually, the formulas which are there in the noise chapter, they are quite extensive. So, any suggestions how to remember that? And there is quite a lot of data coming in for these sessions as well. So,
Mhm. Okay, so what I will suggest to you in the formulas for noise. So most of the formulas don't remember it as P by P, but remember it as P by 20, because 20 is the baseline which we have considered, like 10 log of something, P by P or P by 10. So maybe simplify that formula into just the given term which is given. And remember it for like power, this is the formula. Don't like remember it as sound power or sound intensity. Remember it as intensity and form some sort of a pseudo name or some sort of a pseudo link that is it considers 20 as the base case, because it's log 10 by 10 and the first factor is different. So
right.
maybe having some sort of a pseudo link to that the base case in this is 10 to the power minus something, or the base case for this is 20. So because you will only be given the p value and then you can just calculate it.
Okay.
So maybe just having that sort of pseudonym kind of thing can help you in that case. If you want like a detailed explanation about this, but that would be a lot of extensive reading on your end also. But just to remember it for this lecture, you can just use like pseudonym kind of things and having the base number already in the formula instead of trying to remember p by small p or w by small w, because small w and small p have a associated value to them which
Yeah.
will mostly not change.
Okay.
Okay.
Yeah. Thank you. And there are
Welcome.
also some of the manuals referred to in some of the sessions. So, we will get any questions from that manuals as well, or just those are for reference?
Those are for references only. Whatever is shown in the slides and whatever is discussed in the lecture units which ma'am have shared with you, that will help you. And the questions which we discuss in these problem solving sessions is practice questions, that and the assignment questions. They will
Okay.
help you to understand the depth of and the kind of questions that can come out of each of the week's unit. So
Okay. Yeah.
yeah,
Thank you.
okay, welcome. Okay, if anybody has any other questions. Okay, so if there are no questions, then I will close this session. Thank you so much for attending this problem solving session. And if you have any feedback or if you have any questions, you can put them in the discussion forums as well, or ask a question section as well. And you can give the feedback in the feedback forms which are circulated to you. Okay, the video of this session will be uploaded on YouTube and the slides will be available in the folder, which you can access from the problem solving session tab in your NPTEL course. Okay, so thank you so much.